Year 12. Okay, let's take a look at the multiple choices first. So, you're told that a lift is operated by an electric motor. It moves between the 10th floor and the 2nd floor at a constant speed. I've highlighted that bit because it's really important for the question. One main energy transformation during this journey is... Now, the key here is you might be tricked into thinking it's to do with kinetic energy because it's a lift and the job of a lift or an elevator is to move people. But you're told in the question that the lift is moving at constant speed. So this means kinetic energy, which is a half mv squared, is actually constant because the mass of the lift doesn't change and the velocity also doesn't because the speed is constant. So you know that there is no change in the kinetic energy value, it's just a constant value. So energy being transferred during this journey cannot be to kinetic energy. And so that gets rid of A, B and C, and you're left with D, which makes a lot of sense because there's going to be heat loss to the surroundings in the process, and obviously electrical energy is used to supply the lift. So that's number one. Number two is a ball initially at rest. Oh, I should have highlighted that bit as well. These are all clues, and so I would always be highlighting or circling when I'm in the exam so that I make sure I don't miss key things. Is dropped in the air from a great height. Air resistance is not negligible, so this is important. Which of the following graphs best shows the variation with time t of the acceleration a of the ball? Now, from the instant that a ball is released, it has weight mg, and so it is subjected to acceleration due to gravity, and so even from the rest position, at the moment it's dropped, I know that acceleration is 9.81 meters per second squared initially. And that is because the only force acting at the start is the weight. As time goes on, you obviously still have weight, but you also now have an increasing air resistance. Okay, and at some point the air resistance will match the weight, and so the resultant force on the object falling will be 0. So therefore A is 0, and at some point between the initial A being 9.81 and A being 0, it will just be A is between 0 and 9.81. So I would always suggest drawing things out in the exam so that you can visualise what's going on. You know that it cannot be A or B because the acceleration is not 0 to start with, it's 9.81. So you therefore know it's C or D. You also know that the velocity value is not going to be decreasing at a uniform rate, and so you know you're going to have C. Okay, you will reach terminal velocity where acceleration is 0 sometime later. Okay, think about the fact that initially when acceleration is 9.81, the ball falls quite far through the air before it even starts to slow down, and then as the acceleration drops, the resultant force on the ball is 0. So that's C. Okay. Number 3 then. Again, we're highlighting the key points. A constant force acts on a mass that is initially at rest. Okay, so this means U equals 0. That's important because that means KE, or kinetic energy, equals 0 to begin with. Okay, so that already gets rid of B and D because kinetic energy needs to be 0 to start with. So then we need to look at how the kinetic energy of the mass changes with the work done on the mass. Well, work done is energy in joules, and kinetic energy is also energy in joules. If friction is negligible, there is no heat loss to the surroundings, and so any energy being supplied to the mass is going to increase its kinetic energy, so it's going to be directly proportional. So I'm looking for a straight line graph. As the work increases, so does the kinetic energy. So that's number 3. Number 4, hopefully this one goes okay for everybody. It is just the definition that you need to memorise, and it is the product of the force and the distance moved in the direction of the force is the correct definition. So now let's look at number 5. Okay, so a pump extracts water from a well of depth h at a constant rate of r kilograms per second. What is the power required to raise the water? Okay, so power is energy over time. Okay, energy transferred over time taken. The energy that is being supplied is going to increase its gravitational potential energy, and that is going to be E is equal to mgh. Okay, now I know that I am told a mass divided by a time is what R is. Okay, so I can write the power equation as mgh over t, and I know that the m over t can be replaced by R, capital R, because it's mass per unit time. Okay, so I can now take this down and say power is RGH, and that is what you're being asked to choose, and that's B. Okay, lastly, for the multiple choices, you've got a ball being thrown vertically up and comes back down again. Air resistance is negligible, so there's no energy loss due to air resistance. Which of the following graphs shows how the gravitational potential energy, EP, varies with time t? Okay, so the first thing we're going to do is write the equation. EP equals mg delta h, mass times gravity, acceleration due to gravity multiplied by the change in height. And I know that mg is constant for the ball, so I can say EP is proportional to the height change. Okay, now obviously if the ball is thrown vertically up and then it comes straight back down, that occurs over time. So if we were to plot the point for height against time, we would get a parabolic shape. And because the height is directly proportional to the potential energy, you choose the same looking graph, and that is D.